Hello, welcome back to my channel Study With Me. This time I will explain subtopics 1.2.1 and 1.2.2, structures 1.2 from the first theme. So it's about the atomic model and isotopes. We are talking about atom. Atoms are the smallest recognizable parts of elements. There are 118 types like you can find on the periodic table. And only a few atom types like oxygen, carbon, hydrogen, nitrogen, calcium, phosphorus make up over 98% of the human body. And these atoms consist of three subatomic particles like protons, neutrons, and electrons, forming the basis of our entire world. And from the structure 1.2.1, you need to know how to use the nuclear symbol, this is the symbol, to deduce the number of protons, neutrons, and electrons in atoms and ions. Relative masses and charges of the subatomic particles should be known. Actual values are given in the data booklet, and the mass of the electron can be considered negligible. Right. Atoms contain a positively charged dense nucleus composed of protons and neutrons, also called nucleons. Negatively charged electrons occupy the space outside the nucleus, like this. So here is the nucleons, consists of protons and neutrons, and on the shells is the electron. Protons has positive 1 charge, neutron is neutral, so it's 0, the charge. Electron is negatively charged, so -1. So this is the simple representation of atom. This is what do we call the nuclear symbol, okay? So these are the elements, for example, Ca. And A is the mass number. So Ca has mass number. Let's see the periodic table. It's 40. Okay. So A is 40 and the atomic number is 20. Okay. This 40 is the number of neutron plus proton. Okay. And Z is the atomic number. The same with number of proton. For the neutral atom, number of protons is equals with number of electrons. Right. Let's do this exercise. So atomic symbol oxygen, atomic number, oxygen is 8. Mass number is 16. So atomic number is 8, mass number is 16. So protons, the same with the atomic number, this one. So X, A, and Z, this one proton number, and this one number of proton equals to plus number of neutron. And in neutral atom, number of proton, the same with number of electrons. So proton also 16, proton should be the same with atomic number. So 8, electrons the same. 13, atomic symbol is aluminum. So proton the same with atomic number, which is 13. Neutron 27 minus 13. Okay, because mass number is the sum of number of proton and neutron. So this one would be 14 electrons. Also 13, yeah. 85, let's see 85. 85 is element of rubidium with the atomic number 37. So this one 37, rubidium, and the number of neutrons, mass number minus number of proton, which is 48. Number of electron, the same with number of proton, 37. Mass number 80, let's see on the periodic table. So 80 is Br, atomic number is 35. So atomic number 35, it's bromine, and protons the same with atomic number 35. Neutrons, mass number minus protons number, which is 45. And next, atomic number 27, it's copper. Okay, we can see here, it's cobalt. Okay, yeah, cobalt. So CO, and mass number is 59. And protons number the same with atomic number. And electrons also the same with the atomic number or protons number. And now we are talking about ions. Okay, it has charge. Positively charged or negatively charged. So positively charged, positive ion, also called cation. Negative ion called anion. Right, let's do this. So protons number, it's 17. Neutron number, 35 minus 17 is 18. Electron number should be 17, right? But it's negatively charged. So we've got one more extra electron. So it's 18. And for this one, proton is 26. And then neutron, 56 minus 26 is 30. And then electron, 26, but lose 2 electrons. So positive charge, losing the electron. Negative charge, gaining the electron. So it has extra electron. So this would be 28 because, 24 because lose electron. And for lithium ion, positive here. So lose 1 electron. Proton is 3. Neutron, 7 minus 3 is 4. Electron, it should be 3, but lose 1 electron, so 2. And for aluminum ion, okay, Al, so proton here is 13. Neutron, 27 minus 13 is 14. Electron should be 13. Lose 3, so it becomes 10. So the conclusion is for cation, number of electron is smaller compared to number of proton. And for the anion, number of electrons is bigger than number of proton. Isoelectronic species have the same number of electrons. Identify the following isoelectronic species by giving the correct symbol and charge. The first one has been done an example. Okay. So here, number of protons 20. So here is 20, right? Number of neutrons 20, number of electrons 18. Because number of protons should be 20, number of electrons should be 20, but because of 2 plus, lose 2 electrons. And here, number of proton 18. So we need to find 18. What element 18? Ar. Okay, so let's write Ar with mass number 18 plus 22, 40, right? And then positively charged, negatively charged, or neutral? Neutral, because the same number of electrons, the same with number of protons. So there is no charge here. 19, number of proton, atomic number is 19. So it's potassium. Okay, so potassium with the mass number 19 plus 20, it's 39. So what about the charge? Here is number of electrons 18, so it means lose 1 electron. If lose 1 electron is plus 1. 17, number of proton is Cl, chlorine. Okay, so the mass number 17 plus 18, 35. Okay, it has charges? Yeah, it has a charge. So number of proton is 17, but number of electron is bigger, has extra 1 electron, so -1. What is the difference between two neutral atoms represented by the symbol? Okay, so we've got carbon and neutron. So the difference between these two, we compare now 6 and 7. Here is, this one is proton number, different. Proton number, different. What about neutron? 14 minus 6. Okay, so 14 minus 6, it's 8. 14 minus 7 is 7. So it's also different from neutron. Number of electron, of course, also the same. Number of different. Number of proton, sorry, number of electrons for nitrogen 7, carbon is 6. So all of them are not the same. Right, next we're talking about isotopes, where you need to know how to perform calculation involving non-integer relative atomic masses and abundance of isotopes from given data. Differences in the physical properties of isotopes should be understood, and specific examples of isotopes need not be learned. Isotopes are atoms of the same element with different numbers of neutrons. Let's see. These are the isotopes of carbon. There are 3. The mass numbers are not the same, 14, 13, and 12. But the atomic number, of course, they're the same because it's the same element, carbon. So it will have the same number of electrons. But neutron here, 12 minus 6 is 6. 13 minus 6 is 7. And this one neutron is 8. So mass numbers are different. Also neutron numbers are not the same. So isotopes are different atoms of the same element with a different numbers of neutron, right? 6, 7, and 8. As a result, they have different mass number, but the same atomic number. The same atomic number because it's the same element. Okay? So protons, they have similar chemical properties because they are carbon, okay? But different physical properties because this one is heavier. So for this one is heavier because the mass number is 14 compared to this one. So physical properties of isotopes are not the same. Only they have similar chemical properties. Right. So next, about relative atomic mass and natural abundance. Okay, natural abundance you see here is a percentage, right? So natural abundance is always in the percentage 100, okay? So the relative atomic mass is listed for each element on the periodic table, and the relative atomic mass is not a whole number because it is weight average of all isotopes of that element. For example, Fe, there are 4 isotopes, 54, 56, 57, and 58. So from these 4 isotopes, we can calculate the relative atomic mass through this way. So the mass number of each isotopes times its natural abundance. So 54 times 5.845 plus 56 times this, 57 times this, and 58 times this one, and divided by 100 because it's a percentage. Natural abundance, so the total we can say like 100 atom. So the relative atomic mass is 55.91. So the relative atomic mass of Fe is 55.91 because it has 4 isotopes with the weight 54, 56, 57, and 58. Okay? Next, let's calculate this one. So there are 2 stable isotopes chlorine. They are 35 and then 37. Calculate the natural abundance. So the AR is known, but we need to calculate the natural abundance. So we can do this way. We still AR, right? 35, right? 35 times, we can just say this is X maybe, and this one 100 minus X. So 35 times X plus 37 times 100 minus x divided by 100. So here we substitute with the AR number that is already given. So 35x plus 37x plus 3,700 divided by 100. Okay, so 3,545, we multiply this, right? And then this becomes minus 2x plus 3,700. So x would be 3,700 minus 3,545 divided by 2. Then x is 77.5. And for this one, for chlorine, 35. So this Cl 35, and then Cl 37 would be 100 minus x, which is 22.5%. Okay, don't forget to write the percentage because it's a natural abundance. Next, lithium has two isotopes, Li6 and Li7. So Li6 7%, Li7 is 93%. Calculate AR. So the mass number minus its natural abundance. So 6 times 7 plus 7 times 93 divided by 100. And we get 6.93. So the relative atomic mass of lithium is 6.93. Next, iridium, okay, IR, has a relative atomic mass of 192.22. So 192.22 equals to, because the question is the percentage composition, again, the natural abundance, okay, because it's percentage. So we've got 191 and 193. So let's make it again for 100. We can just do it, for example, 191 is x, and 193 is 100 minus x. Okay, so 191 times x plus 193 times 100 minus x divided by 100. It's the same with the one that when we calculate for the natural abundance this of Cl. Okay, so this would be 19,200, okay, 222, and this one would be 191x plus 193, no, minus, okay, because it's minus x, and then this one is plus, right? Sorry, this one should be minus. I make a mistake here, but anyway, 35x minus 37x, so negative 2x. Okay, and then plus 19300, right? So x would be 19,300 minus, this would become negative 2x, yeah? And this one would be 19222 divided by 2, which is 39. Right. So for the IR 191, okay, this one x, 39%. And then for IR 193 would be 61%. Okay. Next, lead has a molar mass of 207.2, assuming that it is composed entirely 206 Pb, 207 Pb, and 208 Pb. So there are 3 isotopes for lead, and that the percentages of the 2 heaviest isotopes are equal. So these 2 are equal, the heaviest, okay, because two heaviest isotopes are equal. So calculate the relative percentage of these isotopes in the natural element. So because they are equal, so I can just say for the 207 Pb and 208 Pb, X, and then 26 Pb could be 100 minus 2x because they're equal. So this one will be X, this one will be X as well, right? So that's why Pb 206, 100 minus 2x. Let's do the calculation now. So the 207.2 equals to 207 times x plus 208 times x plus 206 times 100 minus 2x divided by 100. So this will be 27,200. So 207x plus 208x minus, so 206 minus 2x, and then so this one would be 412x, right, plus 2600 divided by, no, because I already multiplied this, right? So this would be this one 3x. So 3x, this one minus this one would be 120. So x would be 40. Therefore, x 40, 100 minus 2x is 20. So 207 Pb is 40%, 208 Pb 40% as well, and 20%, right, is for 206 Pb. Let's go back here. Linking questions. So what determines the different chemical properties of atoms? Their atomic structure, valence electrons, type of bond, and atomic size. So this makes or cause or influence the chemical properties of atoms, because the atomic structure that determines number of protons, electronic configurations, so this will give a different chemical properties. Also valence electrons, so atoms with similar valence electrons exhibit similar chemical properties. Type of bond, you know, the ionic covalent bond, so this will determine whether an atom lose or gain or share electron. And the size of atom, it will determine the reactivity, like the ability to attract or lose electron. The second question, how does the atomic number relate to the position of an element in the periodic table? So the atomic number relate to the position of an element in the periodic, as elements in the periodic table are arranged in increasing order of atomic number from left to the right, from top to the bottom. And also the periodic table is structured into period and group based on the atomic number. And the element identity as atomic number is unique to each element, where no two elements can have the same atomic number. All right, so that's all for the explanation about we talk about the structure of atom, like calculating the subatomic particles like protons, neutrons, electrons for both neutral atom and ions. We also talk about isotope and its properties, what is isotopes, and then we'll also talk about the relative atomic mass and natural abundance. Okay, so that's all for the videos today. Thank you for watching. If you haven't already, please subscribe to the channel and do not forget to share it with friends who might benefit. Be sure to join the WhatsApp and Telegram channels to stay updated on the community, where I plan to hold live classes. You can find the link of WhatsApp and the Telegrams in the description. And once I launch the community, I will hold live classes, answer your questions, and work through IB style exam questions for each topic. Your support means everything, and see you in the next video.